Hello, this is my Physics 2212 Lab 4 magnetic field of a bar magnet. The purpose of this experiment is to measure the distance dependence of the magnetic field due to a small bar magnet and simulate the magnetic field of the bar magnet using glow script before comparing the simulated field to those previously derived using Biot-Savart law. Some fundamentals are the previously mentioned Biot-Savart law, which determines the magnetic field generated by a small, constant current carrying conductor for the distance between the source of the field and the ops location, with some adjusted equations depending on if we are far from the loop and through the center of a loop, and the equivalency of the magnetic dipole moment with same direction as on-axis mag field and conventional current I. Some other equations relating to the Biot-Savart law include the magnitude of the mag field of a magnetic dipole on the perpendicular axis, the direction of the perpendicular axis opposite to magnetic dipole moment, and the generalized formula for the mag field of a magnetic dipole. In our experimental setup, the system is the observation point and the surroundings are the bar magnet, with the initial conditions that the bar is treated as a magnetic dipole. For the procedure, some materials needed are a bar magnet, a magnetometer, a meter stick, and tape, where we will adjust our mobile device in order for the magnetometer to have an X component of 0. Then we will need to determine where the magnetometer of the mobile device is located, as well as determine the on-axis magnetic field by measuring the space between the magnet and magnetometer. The magnetometer is on-axis compared to the magnet's dipole axis on account of the following the X components of the magnetic field. Measured thresholds include 20 Tesla, 70, 120, 170, 200, with 3 measurements per magnetic field, as well as we need to determine the off-axis magnetic field by measuring the space between the magnet and magnetometer. The magnitude of the net mag field will need to be 100 Tesla. Recording the Y component of Earth's magnetic field, apply distance in the Y direction and adjust magnetometer to this new distance before measuring the magnetic field once again at this point and repeating the process twice more. Here are the tabulated values and graphical representation. Some observations that can be formed from the data is that where the magnetometer is farther from the magnet, there is almost a near zero magnetic field in the X direction. As the magnetometer moves closer, the mag field's X component increases. The following equation is equivalent to the previously viewed regression line from the collected data, with the slope equaling n and the y-intercept equaling natural log of k. By solving for k using Euler's constant and the exponential function, the following equation can be constructed to determine magnetic dipole moment. An adjusted magnetic field towards the y direction was determined by calculating the difference between Earth's magnetic field and the measured y component of the magnetic field at its off-axis location. Here are the constants and magnetic field components of the glow script code. Here are the arrow scaling components of the glow script code. Here are the off-axis magnetic field and magnetic field arrow components. Here we can see the computational model results. As the distance between the ops location and magnet decreases, the magnitude of the mag field increases. Our calculated dipole moment comes out to 3.995 amperes squared. Experimental magnitude of off-axis magnetic field can be seen here with a magnitude of 4.63 times 10 to the negative 5. Our simulated magnitude of off-axis mag field can also be seen here with a magnitude of 4.29 times 10 to the negative 5. Some possible sources of error are other sources of magnetic fields distorting the measurement error with the magnetometer, and surface inconsistency in finding a completely flat location to take measurements. What if you hadn't oriented your experiment to compensate for magnetic north and instead laid out your meter stick at some intermediate angle? How would your results have changed? The measured magnetic fields would have changed due to no longer accounting for magnetic north. The X component would have changed since magnetic north would have contributed to the measurements, while the Y component would have also changed due to not accounting for magnetic north. Since the magnetometer measurements are taken on a flat surface, the Z component would not have changed. If we were to stick two identical magnets together, the mag field's magnitude would increase due to the combined magnetic fields from both magnets. Therefore, it could be inferred that the magnitude of the new mag field would be double the previous one. The measured distances for each mag field would decrease due to the increased mag field magnitude due to both magnets. Thank you.